Hello everyone, welcome to my channel. Today we'll see certain examples from chapter number 22, Conjugate addition and nucleophilic aromatic substitution from Claydn. Now let us start with this example. So now let us see what is the product formed here. First of all, since AlCl3 is a Lewis acid, so Lewis acid means it is going to accept electron, and now since oxygen has its lone pair of electron, so it can give it to the aluminium and it will form double bond O AlCl3, and there will be generation of negative charge on aluminum and a positive charge on the oxygen atom. Since positive charge is generated in the electronegative oxygen atom, so further it gets stabilized. It will go here and then it will form O AlCl3 minus, and there will be a positive charge on this carbon atom, and then this bond will go here and we are going to get LCl3 minus. There will be bond, and this carbon cation is going to be get formed because it is a tertiary carbocation, so it is very 3-degree carbocation, so it is very stable. So this carbocation is going to be formed, and then the benzene, this pi bond, is going to attack here this carbocation, and it will give us O LCl3 minus. And then in the next step, since there is a positive, there will be generation of positive charge here, and it has lost its aromaticity, right? So further this hydrogen is going to get lived, and thus there will be regain of the aromaticity here, and we are going to get this. I'm writing like this. And now in this question it has been given finally aqueous 4 cup, means this will leave and there will be OH, okay, due to aqueous 4 cup. And then it is enol type of form, so further it goes into the keto form, which is more stable product. Okay, so further the final product of this reaction is this one. Now let us move on to our next question. So now this one is 2-chloropyridine and this one is 3-chloropyridine. On reaction with an amine, what is going to be the product? Now here this nitrogen acts as a nucleophile and it will attack at the electron deficient carbon center. So now which is the electron deficient carbon center here? This carbon center, right? Because chlorine is an electronegative group, so it will withdraw the electron density, therefore it becomes electrophilic, right? This carbon atom, so it is going to attack at this carbon atom, and this bond will, and this bond will go here, and negative charge will be on the nitrogen atom. This is going to be the intermediate formed in this reaction. And we know chlorine is a good leaving group, so further in the next step this negative charge is going to get here, and this chlorine will leave and it will give us our product as this product, right? Now let us see the second case. In the second case, this one is 1, this one will be 2, okay. It is 3-chloropyridine on reaction with an amine. Now we have to see, now we know this will be the electrophilic center. Now attack on this carbon, then this double bond will go here and this double bond will further get here, but there will be, but the negative charge is not generated on this electronegative nitrogen atom this time, so this reaction is not going to get further proceeded, so there will be no reaction. Okay, no reaction when it is at the 3-chloro. But if the question comes that there is 4-chloropyridine, now will the reaction proceed? Yes, it is going to proceed. Why? Because it is going to attack at the carbon and this bond will get here, and again negative charge is going to be get generated on the electronegative atom, so reaction will further proceed here and it will finally give our product as like that. So when there is ortho and para substituent leaving groups are there, then only the reaction will proceed. nucleophilic reaction will proceed here. Okay, now move on to our next question. So this one is paramethoxytoluene, right? So on reaction of chlorine, what will be the product first? Now, which is a very good donor, methyl or methoxy? OM is good donor or Me? Now Me is going to donate its electron through plus I, and OM is going to donate its electron with the help of mesomeric effect, plus M. So now we know that mesomeric effect dominates over inductive effect. So OM is a good donor as compared to methyl. Now chlorine is given. So this will go form here a double bond, and this bond is going to attack the chlorine, and one chlorine is going to leave, and it will give us Cl double bond OMe and positive charge. Then in the next step, this hydrogen will lose, and the aromaticity is again regenerated. Okay. OMe Cl, and then in the there is a methyl group, and then the next step NaNH2 is given. NaNH2 means it is minus, it is plus, and since there is hydrogen atom present here, so this NH2 is going to abstract this proton, and since this is an aromatic ring, so it can be also written as, it is also same only. OM is a good leaving group, so this negative charge is going to abstract the proton first, and there will be a double bond, means there will be formation of a benzene. Okay, this chlorine will leave, and it will give us formation of benzene. Now in the next step, since benzene is very reactive, okay, so since NH2 is further present in the solution, so it will attack now from which side it is going to attack, this side or this side. Just remember, whenever there is a benzene type of system, then it will attack in such a way that if it attacks here and negative charge, then negative charge is going to get formed here. Okay, and this negative charge will not be further stabilized, but if negative charge forms here, then it will be stabilized by this inductive effect. Always consider the inductive effect in case of benzene. Okay, so it will attack here and here, and negative charge will form here. In case of benzene, always consider the inductive effect, because there is oxygen, and oxygen is a more minus I is there. Okay, minus I, so it will stabilize this negative charge, and then further it is going to abstract a proton, and thus finally gives this our product. Let us see our next question. So what are the products formed here? This is a cis-alkene, right? And this is on reaction with hydrogen peroxide in presence of OH minus, and what will be the product formed when it is reacted with metachloroperbenzoic acid, MCPBA. Okay, you know one thing, that whenever there is a peroxide or MCPBA, both are going to give epoxide. Okay, but the difference is that whenever you are given a cis-alkene with hydrogen peroxide, then it is going to give a trans epoxide is going to form. Okay, whenever there is hydrogen peroxide, a trans epoxide is going to get formed, that is trans epoxide will form. And whenever you see MCPBA, cis will become cis only, and it will give us cis epoxide. Okay, this you need to remember this one. Okay, now let us move on to our next question. So in this reaction, what will be the product formed? First of all, base is given, right? And the role of base is, it is going to abstract a proton, and it is going to abstract the most acidic proton. So this hydrogen it is going to abstract it is as it is attached to the sulfur atom. So further a negative charge will be generated on the sulfur atom. Okay, that is bromine, and this sulfur atom has a negative charge, and then nucleophilic attack will take place. Now since chlorine is good leaving group, so nucleophilic attack will take place. Now there is two possibility. It can attack. Will it attack from this side or will it attack from this side? Okay. Now if I consider attack takes place from this side, then this pi bond is going to get here and this pi bond is going to get here, but it does not stabilize this nitro group. Okay, from if it attacks from this side, it is not going to stabilize this nitro group, but if it attacks from this side, then this pi bond will get here and negative charge will be generated here. Then this negative charge is further can be stabilized as this will come here, and further negative charge will be in this oxygen atom. So further stabilization of this negative charge will be there if it attacks from this side, means there is S and that group I am writing as R. Okay, thus it will give us our product as, means it is going to be first double bond and O minus S. I am writing S and the whole group as R. Okay, and there is a chlorine, and then in the next step this negative charge will get here and this aromaticity is again regained in the system, and chlorine being a good leaving group, it will leave and it will give us NO2 and S. Now I'm writing the whole structure. Okay, Br. So this will be the final product of this reaction.